Hey, good morning, everybody. Quick little tutorial on developing the projection vector. This is, I think, just a totally remarkable use of mathematics that takes us from, hey, I can see it to, wow, we got to develop it and really kind of understand where it comes from so we can believe in it and trust it when we see it. All right. So what is the projection vector? Um, Notice I have two vectors. I have n right here, and I have A. So there's always an angle between the two vectors. That's great. But so what we say is how much of one is in the direction of the other. So that is going to be at our perpendicular. So if we say the projection of A onto N, so that is going to be given like that. Now, the projection itself is actually a vector. Only I'm just going to talk about that distance right now. If we wanted to get the projection vector, then we would take that distance, that h, and multiply it by the unit vector in the direction of n. So we did those little exercises of finding the unit vector, and that's where we would take it. But right now, let's just stay with, we're looking for that distance. I conjecture that all we have to do to find that length h is dot product the two and divide by the magnitude of n. The dot product is one of the easiest things to do. You just multiply the x's, multiply the y's, multiply the z's, and add them up. That is easy. The magnitude, once again, super easy. So this is where it comes from. And I think both of these steps are things that you can believe in, and that's the goal. First of all, we know that the cosine of theta right here is equal to adjacent over hypotenuse. So adjacent over hypotenuse. I write it as the magnitude of A because hypotenuse isn't a vector, it's a length. All right. So we might clean that up and say the magnitude of A cosine theta is equal to H. And that actually works great. If you want to find theta, you can and plug it into this formula. It works great. In fact, where would we get theta? Well, with vectors, we know that the dot product is equal to the magnitude of A, magnitude of N, cosine of the angle between them, right? So this is something that you've got to kind of actually have in your back pocket. You got to believe in. Um, we can develop it again and again until you've done the algebra, but you got to have that one. You got to know that that's how you get the angle between the two vectors. All right, well, I notice we've got the A cosine theta, and we've kind of got it on this side. So all I'm going to do is divide both sides by the magnitude of n, and I get the magnitude of A cosine theta, which, according to our super easy SOHCAHTOA, is equal to h, and we have done it. We have actually shown that you can get that distance by just taking the dot product over the magnitude of n using two very, hopefully, basic ideas. Quick example, let's say this vector n is 1, 5, 9. We got this vector 2, negative 1, 3, and I would really like to know what h is. So I would write h is equal to the magnitude of the projection vector of a onto n. You'll see that written different ways in different books. That is just a dot n over the magnitude of n. And a dot n, last time I checked, is 2 plus negative 5 plus 27 over the magnitude of n, which would be 1 squared plus 25 plus 81. And we get a crazy 24 over the square root of 107. And that is it. That's it today. Why would I do that? You may run into a problem that looks something like this. This is called a tetrahedron. Um, what we've done is kind of cut that base in half. It used to be a parallelogram. Maybe that would be important. So when we find the volume of a pyramid, it is 1/3 the area of the base times the height. Capital B stands for area of the base. Lowercase b would be like a length of a base, like a rectangle. So that's pretty cool. Well, we already know that if I want to find the area of a parallelogram, it's going to be the magnitude of the cross product or vector product of the two vectors. So the triangle is going to be 1/2 OB cross OA. And the height of this thing is going to be this length right here. And maybe you can see it clear as day now why I went over the projection of a vector like this one onto a vector like this one to get the height. So this would be the projection of A onto N. So we get 1/6 times OB cross OA. At this stage, hopefully you're good at that. And then to recognize that this is nothing more than A dot N over magnitude of N. That's not intuitive. That is not something you walked in a week ago and said, how about we can find the volume using the vector product, the dot product, magnitudes, and 1/6. That is amazing stuff. And if you're not solid with the base, it's not going to last. So try, challenge yourself to develop those things. All right, just going to have you practice some problems today and end up with the volume of tetrahedron. Have an amazing weekend and keep your eye out. I'll probably send you something on Saturday or Sunday to get ready for Monday. Toodaloo.